Hey everyone, welcome to part 2 of my Build Your Own NPM library series. First, I just want to say a big thank you to everyone who watched part 1, and especially to all of you who subscribed to the channel and gave part 1 a thumbs up. In this video, I'm going to set up a unit testing framework so I can take a test-driven approach to writing this library. So unit tests can seem like a pain to write sometimes, but they can actually be quite satisfying to write if you have the right tools. The basic idea around test-driven development is the repetition of a very short development cycle. So first you write a test to define some feature you're looking to add. And that test is going to fail initially. So then you write the minimal amount of code necessary to make that test pass. And then finally you go back and refactor the code until it meets your standards. If you take a test-driven approach to writing code, it forces you to think about things a bit differently and plan more ahead of time. And the real value of good tests comes when you start adding more features to whatever it is you're building. If you write good tests, then they'll help you catch breaking changes that you might not have intended to introduce. So most of my experience writing tests in JavaScript has been using Jasmine, but I wanted to switch things up and give Jest a try since I've heard really good things about it. It's ridiculously easy to set up, but there were a few little gotchas that I found along the way. So the first thing to do is to install our dependencies. So I'm going to install some dev dependencies. I'm going to get Jest, tsGest, since we're using TypeScript, and I'm going to grab the Jest types as well. All right, great. We got those dependencies. Now, if you're using vanilla JavaScript, Jest doesn't require any configuration to get running. But since we're using TypeScript, there is some minimal configuration that we need to do. Luckily, there's a command that we can run to initialize our config. So I can run npx tsGest config init, and that's going to write our Jest configuration file for us. So by default, it's going to use Node as the test environment. But since this is a library that's intended to be used by front-end applications, I'm going to use JS DOM instead, which makes sense, JavaScript for the DOM. I'm also going to add a root directory, just so Jest only scans the source folder to look for test files. And that's it. That's all the setup that we need to do. So the first little gotcha is that Jest is going to look for files that match test.ts. So I have to rename this file to something else, or else Jest is going to think that it's a test file. So I'm just going to rename it to scrap, since I plan on scrapping it anyway. So let's create a couple of functions, and I'm not going to implement them yet, and I'm going to write some unit tests that will fail initially, and then I'm going to write some code to make the test pass. So I'll make a function test1, doesn't do anything, and a function test2 that doesn't do anything. So now we're ready to write our unit tests. So I'm going to create a new file. I'm going to call it scrap.test.ts because Jest is going to detect that .test.ts as a unit test file. So the first thing I'm going to do is instantiate one of those my test classes. And first I'll write a test that's going to pass. So the unit tests are really easy to write. So I can say test my test class.hello should call console.log. And I can spy on console log. So that way Jest will detect if console.log is called. Then I'm going to call obj.hello, and then I'm going to expect that console.log to have been called. So expect console.log to have been called. So the test is really intuitive to read. So let's try running this. I'm just going to run Jest, see what happens. Look at that, our test passed. So far so good. So now let's write some tests that are going to fail, and then we'll go back and implement the code to make them pass. So I'll say test my test class dot test1. I'll say should return hello. Should return the string hello. So I'll say expect obj dot test1 dot to be hello. And for the second one, let's say that test2 should return a promise. So we'll expect obj dot test2 to be instance of promise. So these tests should fail, which is what we expect, and they do. So let's go ahead and make those tests pass. So we expected that test1 would return the string hello, so let's return hello. And we expected that test2 should return a promise. So let's say return new promise, and we'll just resolve the promise right away. Now if we run the tests again, they should pass. And they do, so that's good. So now let's add some more requirements to test2. Let's say that my test class dot test2 should resolve with hello. And since test2 returns a promise, we can use async and await. So I'll say the callback is an async function, and we'll say const val equals await obj.test2, and then we'll expect that val to be hello. And this test should fail, and it does. So let's make that one pass. So we'll resolve with the string hello. and run it again. And there we go. We have 4 passing tests. So that was a really tedious example. In real life, you're probably going to write more test cases up front before you start implementing things, but I just kind of wanted to show you that flow. So I'm going to end this one here. Thanks for watching. I'd really appreciate it if you give the video a thumbs up and hit the subscribe button if you don't want to miss the rest of the series. I'll catch you all in the next one.